Take out your notes. We have our last lesson of 2020, 6.5. We are just doing operations with radicals today. All right, so no graphing, just lots of simplifying today. Lots of simplifying. All right, so here we go. First off, when we simplify, a couple of things. When you multiply radicals, let me highlight this, okay? You can actually use this property where you can like put radicals together or you can like split them apart. So what I mean by that is if I have like, let's say cube root of 2 times cube root of 9, that would equal to the cube root of 18. All right, so you can go ahead and multiply those inside the radical together and make it one radical, okay? All right, and then the same thing happens with dividing this guy right here. You can split the radical. So if I have like cube root of, I don't know, 9 divided by cube root of 3, you can make that cube root of 9 over 3 to be the cube root of 3. All right, so you can do things like that. All right, so multiplying, dividing in the radicals is definitely allowed, okay? You cannot do this with plus or minus though, so keep that in mind. You can't do this with plus or minus. So I'll show you guys how to do that later. All right, so let's go ahead. We're just gonna simplify a lot. Ethan is putting $3.50 on the table. All right, can anybody beat $3.50? Thank you, Ethan. All right, let's go ahead and try simplifying. So first off, let's go ahead and let's factor tree out the 540. All right. So let me call on people. So 540, think about, you know, two numbers that multiply to be 540. All right. I'm looking at the chat. Man, I don't think you guys know how much an iPad is worth. Thank you for the offer of gummy bears or gummies. And I don't know what 351.1 means. Oh, thanks, Leo. Okay, Leo is focused. Thank you. I appreciate that. All right, so Leo says 60 times 9. Good. Another one you can do is 54 times 10. Yes, Chris, you can go to the bathroom. All right, keep going. What breaks down 60 or what breaks down 60? Keep breaking it down. Go ahead and type in the chat or unmute yourself. Or I can call on somebody. What two numbers multiply to be 60? Nice, thank you. Ooh, all right, I got lots of different ones. Good, all right. I saw this one first. 30 times 2, okay. Once you get to a prime number, like you can't factor it anymore, I would circle it, all right? Circle it, and that way, you know, you can see it better. Let's keep breaking down the 30. Somebody break down the 30 for me, please. Nice, thank you. Thank you, yes. All right, I'm gonna circle the 2 and break down the 15. Good, yes, good, yes. I see lots of right answers, good. All right, circle it once it ends. All right, now notice I have the 9 not circled, so I have to break down the 9. So help me break down the 9. Good, good. Yes, lots of right answers, good. All right. So that's the first step when you want to simplify a radical. Break it down, see what this is called prime factorization, right? So break it down all to its primes. Okay, so now remember the bouncer. What is the index in this radical right here? What is the hidden index or understood index? Good, yes. Good, I got 2 right answers. Good, perfect, because that answer is 2. All right, so the hidden index is a 2. All right, so this is a square root. So the bouncer says you need 2 people. You need 2 of the same number to get out of the root. So let's see, I have 2 2s. All right, so I'm going to take that out. I have 2 3s. I'm going to take that out. And that's all I can take out, right? The extra 3 and the 5, there's no other 3, there's no other 5. So these guys stay inside the radical. All right, and then you multiply. So this is going to be 2 times 3, which is 6. And left all still inside the radical is the 3 times 5, which is 15. All right, and that's how it's done, guys. That is how you simplify a radical. Okay, let's do number 3. I'm going to do the odd ones, and then if you guys want extra practice or you want me to show more, I will go back for any even ones you want to see. All right, so put in the chat if you want to see any of the even ones, but I'm going to move through the odd ones for now. All right, number 3, I have negative 4th root of 405. Negative 4th root of 405. Don't let this negative like mess you guys up, okay? Just know that you're going to have to tack on that negative at the end of the problem. So let's just focus on this, the 4th root of 405. Okay, let's break down the 405. What 2 numbers multiply to 405? Go ahead and type it in the chat. Ooh, nice. I got 81 and 5. Good. All right. And then 5 is done. So I'm going to circle it. What about the 81? Good. Yes. Good, guys. Lots of right answers. Nice. Okay. And then 9 can break down to be? Good. Yes. Nice, guys. Awesome. I'm loving this chat participation. Great job. All right. So I got 3, 3, 3, 3, and then a 5. Okay. So look at the bouncer. The bouncer says you need 4 of the same number. You need 4 of the same number. So I got 1, 2, 3, 4 3s here. So the 3s can all come out. All right. So that's done. But this 5 doesn't have enough to come out of the root. So I'm going to stick the 5 back into the rad. Now here is where students will make a careless mistake. Look at that answer, guys. What is missing? What is missing? Put in the chat if you know. What is missing from this answer? So I'm like this close. Good. I got 1 person who sees it. What is missing from this answer? No, but good guess. Person who just put that with the question mark. Oh, good. Okay. Not plus or minus. No, but yes to the person who put a number down. Good job. All right. I got 2 right answers and 2 good guesses. All right. I am missing the 4, the index. All right. That is probably the number 1 careless mistake I see is students just forget that little number because we're so used to just writing the square root without the number there, right? So try just to be careful with that little detail. And just know on the quiz, I'm not writing this quiz, so I'm not exactly sure how the teacher's going to ask you to type things out. My response to that, though, is guys, don't worry about little typing things like this. Write your work and answer on your sheet of paper, box it really clearly, and then in Schoology, just type answer on paper. And that way you don't have to worry about like, how do I type this index of 4? Okay, so just write answer on paper and then you're good. Okay, let me go and take a pause. Any questions on just simplifying radicals with numbers inside? You can type in the chat, or if you want to see one more, you can also type that in the chat. If not, then I will move on to simplifying with variables on the inside. Okay, it seems like nobody is asking for number 2. Okay, then I will move on to number 5. All right, so number 5, we have some variables here. Okay, so it's actually very similar. It's just the same thing we did before. First thing is start with the number, and I'm gonna break this down to be 2 times 2 times 2. Okay, so you don't always have to just have 2 branches. You can have as many branches as you want. So I see I have 3 2s. So the bouncer says, yes, you can leave the radical. All right, so I can take that out. And oops, this is why I need a new iPad. Okay, and then we have the 2s come out and nothing left inside the root. So done with that. All right, next is g cubed. All right, remember, divide the exponent with the index and I get g to the first. All right, and that is it. All right, and then next, my k, I'm going to divide the index. Okay, now when you divide the index, notice this time I don't get like a nice even divide, like I have a remainder, right? Like if I divide 8 divided by 3, this is 2 and a remainder of 2. All right, so if I do it this way, it might be a little more obvious. So I get 2 and remainder of 2. So what you do is, that means you have 2 sets of k's you can pull out. And then the remainder of 2, that means you have to leave 2 k's in the radical. So I am leaving 2 in there. Okay, so this 2 was this exponent. This 2 is this exponent. All right, and then the last thing I would double check is, do I need absolute value? Does anybody know? Can you put in the chat? Do I need absolute values? Yes or no in the chat. Just yes or no. Do I need absolute value? Good, good, good. Good. Yes or no. Do I need absolute values for this answer? Okay, can anybody explain why? Put that in the chat. I got some right answers. Can anybody explain? Good. All right, I got 2 good answers. Good, I got 3. Nice, good. All right, I think the shortest and sweetest one was from Yanni. So Yanni, can you go ahead and just say what you said in the chat?
Because it's all index.
Good. The index is odd, so don't even need to check. All right. Some people said, well, it didn't go from even to odd. That's another great answer. But if the index is odd, right, the 3 index, you don't even need to check. There's just no absolute values necessary. All right. So final answer, let me write it a little more neatly without all the arrows. Final answer would be 2g k square cube root of k square. All right. Nice. Okay, let's do a few more of these. Let me see if I have another one. I'm assuming you guys probably want to see another one, right? Yeah, okay, let's do another one. Let's see, 4 or 6. I'll let you guys pick. Which one do you want to do? 4 or 6? You can put it in the chat. Or if you don't care, I'll just do number. Oh, okay, I got a vote. Nice. All right, I'll do number 4. All right, number 4. So first thing, let's break down the 48. Go ahead and put it in the chat. What does 48 break down to be? All right, I got an answer. I got 6 and 8. Good. And then I think you guys know how to do this, so I won't ask. All right, so I have 6 breaks down to 2 and 3. 8 breaks down to 2, 2, and 2. All right, I'm going to start calling on people. So listen up for your name. All right, Ethan, help me with this. Ethan, what can I take out of the root from that 48?
You can take out the 2s.
Mm-hmm. And why? Why can I take out the 2?
Because there's 2 pairs.
Meaning I have how many total?
2 or 4.
4, right? And because the index is 4, that's how many you need to take out of the root.
Yeah.
Okay, and then what's left?
Just the 3.
Okay, so what do I do with that 3?
Don't you just leave it there?
Like leave it here?
No. I forget what you do after this. This is confusing.
That's okay. It's a lot of steps, I know. So just leave it in the radical, like that.
Oh yeah, that's what I meant.
Okay, perfect. So leave it in the radical. All right, so Ethan, now, what about the v? What do I do with that v to the 8th?
Do you do the factor tree for the 8?
Easier than that. So look at what we did with number 5. Look at what we did with the g.
Wait, I'm kind of confused.
So are you looking at number 5?
Yeah.
Look at the g to the 3rd.
Okay.
What do we do with that exponent of 3?
Do you divide it by the root on the outside?
Yeah, so that's called the index.
Okay.
Okay, so apply that now to the v. So what happens when we divide?
You get 2.
Good. All right, so then that's v square. Okay? Okay, now do the same thing for the z. What happens?
Isn't it just 13 over 4?
Good. So 13 over 4, what does that give you?
3.25, so 1 over 4.
Good. Okay, so we got a 3 and a remainder, right? This is the remainder.
Yeah.
Okay, so then what do I do with that? So look at number 5. Look at what.
Oh, do you leave it inside the square root?
Okay, so start with, yeah. So let's start actually with the 3. What do I do with this 3?
Z to the power of 3.
Good. Okay, and now what do I do with that
1? You put the z in the square root.
Good. To the power of 1, which we don't have to write the 1, right?
Yeah.
Good. Okay. Good job. All right, now the last thing is, do I need absolute values? So look, first off, do I have an even index?
Yeah.
Yes. Okay, so now I really do have to look. Now, do any of my exponents go from even to odd?
Yeah.
Which one?
Z.
Does it start even?
Oh, no, it doesn't. Sorry.
No. So yeah, z to the 13th, nope. V to the 8th, it starts even, but it ends up being
Even.
So
yeah.
I don't need absolute value. So this
Okay.
is your final answer. Yeah? Okay. All right. Good job, guys. If we have time, we'll go back to number 6, but let's go ahead to number 7 because I want to make sure we get through our lesson today. Okay. Number 7. Great job, Ethan. All right. Number 7. Let's go ahead and simplify. So to simplify this, guys, first off, you just cannot have a fraction in the radical. That's why this is not simplified. You just can't have fractions in the decimal. So from the property we saw before, what we can do is separate the rad, meaning take the rad of the numerator and the denominator separately, like that. Okay. And now we can simplify, all right? The denominator is just gonna be 8b squared, all right? So no more radical, that's great. And then the 9, I can pull out a 3. And the a, when I divide this, I get 5/2, which is 2.5. So that means this gets me a squared. Remainder of 1 leaves 1a in the radical. All right. Double checking if I need absolute values. My index is even, so I do need to check. This one starts even, but it ends up even. So I don't need an absolute value around my B. For A, this one doesn't start even, so I don't even need to worry about it. So that is my final answer. All right. Let me take a pause. Questions, you guys can have a look at that one. Okay, let's do one more of this one. And let me call on somebody for some help. All right, so number 8, I got a 4th root. Let me see, can you help me with this one, please? Let's go to Joanne. All right, Joanne, help me with this one. What do you think we can do first? Ideas, just throw out any ideas.
Factor the radical.
Factor, okay, so factor which part of it?
Like 8.
Okay, yeah. I think what you're already thinking is maybe splitting numerator and denominator and then factoring out that 8, right?
Yeah.
Okay, so now we can actually do this in our head. So 8, what does 8 factor out to be?
2.
2, how many 2s?
2 2s.
The 8? 2 times 2 is 4, so I need one more.
4 2. 3 2s.
I need 3 2s. Okay, so if I have 3 2s, do I have enough to take them out of the radical?
No.
No, because how many do I need?
4 2s.
Yeah, so that's not really going to help me because, yeah, I only have 3 2s. So, okay, that's okay. I can't simplify the numerator. The point is I do need to simplify the denominator though, right? In order to simplify, I can't have a radical in the denominator. So here's the thing. 9, Joanne, what does 9 break down to be?
3 and 3.
3 and 3, okay. Do I have enough to pull out of the radical?
No.
No. Okay, what about the A? Do I have enough A's to take it out of the radical?
No.
No. How many A's do I have?
3.
I have 3. So now the question is, well, I need to get it all out of the radical. So how many 3's do I need?
4 3s.
So how many more 3's do I need?
2.
I need 2 more 3's. Okay, how many A's do I need?
1 more.
I just need 1 more. Good. So I need 2 3's. I need 1 more A, and that will allow me to take both of them out of the radical. Okay, so what we're going to do is we are actually going to multiply what we need for that denominator to be complete. All right, so do you see how I multiplied 2 3's and I multiplied 1A? Yeah, so that's how I know, okay, that's what I need to be able to take those out. So I multiplied And that way I can take out 1, 2, 3, 4 threes, and I can take out 1, 2, 3, 4 A's. And now I have no more radical in the denominator. Okay? So what does that leave in the numerator?
4 rad 72A.
Good. That is it. So 8 times 3 times 3, which is 9. So 8 times 9 times A leaves me with 72A. And I don't have enough to simplify that. So that is it. Good job, Joanne. Does that make sense?
Yes.
Yeah? Okay. Good job. So all you guys have to do is just figure out, what do I need to complete the set? All right, that's all you need to do. What do I need to complete the set? And that is what you multiply right here. Okay, let me pause. Questions on that? All right, great job, guys. I think those are the toughest parts. All right, so we've gone through the hardest parts. Let's get to the easier stuff and simplifying these radicals. Okay, so let me show you guys number 9. All right, number 9, you were just multiplying. So when you multiply, guys, just multiply what's outside the radical together and multiply what's inside the radical together. Now, here's a trick for you. I wouldn't actually multiply 15 times 45. I would keep that separate because we're going to have to factor that out anyway. So this is going to be, actually, let me do a factor tree here. This is going to be 5 and 3. This is going to be 9 and 5. And 9 breaks down to 3 and 3. All right, so that's my little trick. Don't multiply the 15 times 45 because we're gonna have to break it down anyway. All right, so let's see what we can take out. I have 2 sets of 3s here. All right, so I can take out that pair of 3s. I can pull out the pair of 5s. And I'm just left with that 1 3 on the inside. All right, so that gets me negative 180. I think if I multiplied that correctly in my head. Rad 3, and that is my final answer. All right. Sorry, I know I'm going a little quicker just because I can see we are running low on time. So if you guys do have questions, pop them in the chat. I'll be happy to go back to a problem, okay? All right, number 10. Let's go ahead and simplify those radicals. All right, so I am going to break this down, 4 and 12. All right, this is 2, 2, 4 and 3, 2 and 2. All right, so I can take out a pair of 2s, another pair of 2s, and I'm left with a 3 on the inside. All right, so this is 48, rad 3. 75, I'll break down to be 5 and, ooh, brain fart, 17. Hold on. 15. Okay, sorry. I'm like, that didn't feel right. Oops. Oh, nope. Don't want to do that. Okay, 5 and 15. And then this is 5 and 3. All right, so I can pull out my 5, and I'm still left with a 3 on the inside. All right, the 80, I got 8 and 10. This is 2, 2, 2. This is 2 and 5. So I can take out the 2. I can take out another set of 2s, and I'm left with 5 on the inside. All right, so that's 28 rad 5. Okay, so now when you guys add or subtract radicals, it's kind of like combining like terms. you want to see if there's anything with the same radical. All right. So like these two have the same radical part. This guy has a different part. So I can't combine those. So I'm going to combine the first two and I get 48 minus 30 gets me 18 rad 3. And then the 28 rad 5 stays as is. All right. And that is my, oh, did I make a mistake? Oh, yes, sorry. This is 32. Sorry, not 48. All right, so this should be 2 rad 3. There we go.
Mrs. Leong,
Yeah, question.
we do different factors for the radicals, like 48, we do like 2 and 24, or like 40 and 2. Would there be the same answers?
Yeah, you would do the same. Yeah. So if you got 2 and 24, when you break it down, it would be the exact same.
Okay.
Great question. Yeah. All right. Let me just do a couple more and I think that will cover it. All right. So this one, multiplying, we're foiling. So we got 3 rad 2 plus 2 rad 3 times 3 rad 2 plus 2 rad 3. All right, so we just FOIL it out. So multiply, we get 9 rad 4. Multiply, we get 6 rad 6. Multiply, we get 6 rad 6. Multiply, and we get 4 rad 9. All right, so FOIL it out. This is 9 times 2. Plus these two I can combine to be 12 rad 6. And this is 4 times 3. All right, so simplify that down and I get 30 plus 12 rad 6. All right, and that's how you would simplify that. Okay, guys, I think this is going to be our last one. And then I'll go back and show any extra examples you want to see. So number 14, I will do number 14. All right, and sorry if this is going really fast, guys. I will record this lesson, so you guys can definitely go back on YouTube and rewatch any examples that went by a little bit too quickly, okay? All right, so here, I cannot have a radical in the denominator. That's why this is not simplified. So to get it out, when you have a situation like this, where you have like a binomial, you have 2 terms, you need to multiply by the conjugate. If you guys remember that. The conjugate is just the exact same thing. It's just opposite signs. All right, so these signs just need to be opposites. All right, so I'm going to multiply numerator and denominator. Let's go and multiply the denominator first, because it'll simplify nicely. I'm going to FOIL this out. So 4 times 4 gets me 16. The 4 rad 3, negative rad 3 multiplies. And if I add that with the positive 4 rad 3, those will cancel out. So that's why we multiply by the conjugate, because those middle 2 will cancel out. So then the last thing I get is negative rad 3 times rad 3 is just 3. All right. So that's nice. That simplifies down to 13. Okay, let's do the top. We got 20 minus 5 rad 3 plus 4 rad 3. And then that's minus 3. All right, because rad 9 gets me 3. So I just simplified that. So that is 17 when I put those two together. And then minus rad 3. And that is my final answer. All right. And that, I think, are all the different types of problems. The word problem is not bad. You just kind of plug in, so it's not too bad. You guys can handle that. Okay. I think we have time for maybe 1 or 2 questions. So if you guys can go ahead and type in any problem you want to see done that we didn't do, type it in the chat. And I'll go back for any extra examples you guys want to see. All right, I see number 13. Yes, all right. So number 13, multiply by the conjugate. So denominator, I'm just going to change that to a plus, multiply top and bottom. All right, multiplying the denominator, rad 5 times rad 5, that gets me just 5. The outside and the inside of FOIL will cancel out, so I'm not even going to bother. So -2 plus 2 multiplies to be 4. All right, so that simplifies just to be 1. Numerator, multiply, I get rad 15. Multiply, I get plus 2 rad 3. All right, can't simplify, can't combine that, so that's just rad 15 plus 2 rad 3 over 1, which is just rad 15 plus 2 rad 3. Final answer. All right. I think we have time for maybe one more. Any other problems that we didn't do that you guys want to see done? Number 12, got it. All right, so number 12, FOIL, all right? Rad 5 times rad 5 is just 5. Rad 5 times rad 2 is rad 10. Negative rad 6 times rad 5 is negative rad 30. Negative rad 6 plus times positive rad 2 is negative rad 12. Now we simplify. The 10 and the 30, there's nothing I can take out, but the 12, I can take out the 2. All right, so I can pull out the 2. And I'm left with -2, and then the 3's on the inside. I can't really combine anything, so that actually is it. All right, guys, I think that's all the time we have. So check out the homework, practice it, and I'll see you guys tomorrow.